A catalyst is a substance that increases the rate of the reaction, but it remains unchanged at the end of the reaction. I often compare a catalyst to a dating agency. It helps the chemicals to meet, but it doesn't stay in the relationship. So a catalyst allows the molecules to react, so it introduces them by a different path or mechanism. And what that does is it lowers the energy that is required to make the reaction happen. So as a result, the reaction happens faster. So basically, the catalyst puts the molecules into the right orientation so that they meet each other more easily. Catalysts make it possible for reactants to enter a new transition state that has less potential energy. So they provide what is called a new mechanism. In other words, how the reaction happens. They change the how. They don't change the reactants, and they don't change the products. The reactants and the products stay exactly the same. They have the identical energy. But what a catalyst does is it changes how that happens by making a new mechanism or a new transition state. So it goes by a different path. The reaction mechanism is the sequence of events that actually gets you the activated complex. So if I take a look at some graphs over here, normally I would require that much energy to get the reaction started, but if I introduce a catalyst, my activation energy is much smaller as opposed to this large value. So it brings down the activation energy hump, and there is a lower energy state at the activated complex. Another way of considering this is your Maxwell-Boltzmann curve, and that tells you how much energy all the particles have and how much energy is required to get that reaction started. So if I bring the amount of energy required to get the reaction started, I'm going to make it that more atoms are actually able to react. Therefore, they'll react faster. Some catalysts that we get to know in the world, some catalysts are called homogeneous, some are heterogeneous. Obviously, homogeneous, they're all together. Heterogeneous, you can see the difference. The most common one that we know that's a heterogeneous catalyst is catalytic converters in car exhaust systems. And what they do is it's a solid substance that all the impurities and all the nitrous oxides go in, and then they come from the engine. You've got carbon monoxide, which is a poison. You get nitrogen dioxide. You get hydrogen carbide. All of those come out of the car's engine. They go via the exhaust mechanism, which is a solid. It's got very, very high surface area. And in the catalytic converter, they get converted into simple water, nitrogen, and carbon dioxide, none of which are poisonous. Carbon dioxide's a problem. It's global warming gas, and that's another story altogether, but at least it's not a poisonous gas that goes in. Those of you who do life sciences will know about enzymes. Enzymes have a lock and key mechanism where two substances come onto the substrate, and then you land up with a product. So enzymes can either unite two things together or break things up, but the enzyme is very specific, and it is an introduction, either introduces those two substances together or brings them together and helps them to separate out. A catalyst is a substance that increases the rate of the reaction, but it remains unchanged at the end of the reaction. So, the energy of the reactant stays the same, the energy of the product stays the same, but the activated complex has a lower energy, meaning that the energy hump in the energy profile gets lower when you have a catalyst. So catalysts make reactions go faster by decreasing the activation energy.